Good afternoon, class. So yesterday we have discussed about Bayes theorem and concept learning. I'll repeat it again. Yeah, is screen visible to you?
Yes, ma'am.
Okay, right. So here what is the relation between Bayes theorem and the problem of concept learning. Okay, so why we are using Bayes theorem here with concept learning? So if you say, let's see how Bayes theorem and concept learning are related to each other here. Okay, so concept learning means I have told you making the machine learn with some concepts which we provide to that. Okay, providing the training examples so that it can generalize well on unseen data. Okay, so when we give some data to the model, what will happen? The model will be adjusted to that data. Okay, and the model will be developed. When we give any unseen data, when we give any new data to the system, okay, it provides some output which is generalized to that particular data. Okay, so by training examples, machine will understand the behavior of the data, which attribute is playing important role in predicting the output. Okay, so for that purpose we are using Bayes theorem to concept. Okay, so for the purpose we will be using different types of probability formulas here, like product rule, Next is sum rule. Okay. Next, Bayes theorem and theorem of total probability. Okay. So first, what is product rule? So what is product rule? Product rule is nothing but probability of P, A and B. That is A and B occurring together, of a conjunction of two events A and B. So for that we will be using product rule. Where A and B occurs together, there we will be using product rule. For that purpose we will be using product rule. Okay. So here probability of P, probability of P and A, that is probability of A given the details about occurrence of B multiplied by probability, prior probability of B. Okay, so that is the formula here, you can see. So just highlight. So this is the formula. Okay, so where we want to get the probability when both the events are occurring, there we will be using product rule. Okay, next is sum rule. Sum rule is nothing but probability of a disjunction of two events A and we have seen Bayes theorem. So this is the Bayes theorem formula. Next is theorem of total probability. So can you see the screen? Guys, is it mirroring? Hello? Guys, is it okay? Can you see the screen?
Yes, ma'am, we can.
Okay, right. So now, theorem of total probability. So what is theorem of probability? That is nothing but if events A1 to AN, that is nothing but if events A1 to AN are mutually exclusive. That is nothing but mutually exclusive on TNT and if occurrence of one event excludes occurrence of other event. So that is nothing but mutually exclusive. Example ఏంటి అని అంటే, take the example of tossing a coin. Okay. So if you are getting heads, head appears on top. That is nothing but it excludes the chance of tail appearing on top. Okay. So when I toss the coin again, if I get tail on the top, okay, so that is nothing but event of tail on the top occurred and it is excluding the chance of head appearing on the top. That is nothing but mutually exclusive. If A1 occurs, then others does not occur. ఒకటి అయితే ఇంకోటి కాదు అన్నట్టు. So that is mutually exclusive. Okay, so there we will be using this particular formula. If they are mutually exclusive, then all of them will share equal probability. All will be happening at equal probability. So when all are when each and every one is occurring with the same probability, there we will be using this particular, to get that particular we will be using this particular formula. So these are the different basic probability formulas which we will be using in Bayes theorem. So next is brute force based concept learning. Why we are using brute force method? So why it is applied with the Bayes theorem? So to concept learning. Okay, example ఏంటి అంటే, so if you take, there is one Everest. Okay, so can anybody tell who has climbed the Everest first time? ఎవరైనా చెప్తారా? Who has climbed with the Everest first time? Tenzing Norgay. Have you heard this word, name? He has climbed the Everest first time. ఓకే, అప్పుడు ఆయన ఎక్కేటప్పుడు ఏమైంది, ద ఎవరెస్ట్ వాజ్ ఇన్ డిఫరెంట్ వే. మీన్ కొండ ఎట్లా ఉండేది అంటే కొంచెం గుంటలు ఉండేది. ఓకే, ఒక దగ్గర ఎత్తులు, ఒక దగ్గర వంపులు అట్లా ఉండేది. సో వాట్ హీ డిడ్, అకార్డింగ్ టు దట్ హీ హ్యాడ్ క్లైంబ్డ్ ద ఎవరెస్ట్. ఓకే, సో హియర్ brute force is nothing but how we go forward. Okay, so what we are doing, how we go forward with crude method, and then how we refine the concept. So that is by using brute force based concept learning. So we can design a straightforward concept learning algorithm to output the maximum posterior hypothesis based on the Bayes theorem. We are going straight forward. ఏమవుతుంది అని ఏం లేదు, మనం వెళ్తూనే ఉన్నాం, మనకు అవుట్పుట్ వచ్చింది. అప్పుడు మనం ఏం చేస్తాము, దాన్ని ఇంకా రిఫైన్ చేస్తాం. మనకు అవుట్పుట్ కరెక్ట్ రాదు, మళ్ళీ ఏం చేస్తాం, మనం దాన్ని ఇంకా రిఫైన్ చేస్తాం. ఓకే, సో విత్ ద హెల్ప్ ఆఫ్ బ్రూట్ ఫోర్స్, బై అప్లయింగ్ ద Bayes theorem in the concept learning, we will be getting the result. So here brute force map learning algorithm. So for each hypothesis H in H, calculate the posterior probability. So what is happening here? You does not know which is the posterior hypothesis. మీకు ఏది కరెక్ట్ అని మీకు తెలియదు. You does not know which is the best among all the hypotheses. Training example ni model ki icharu. Okay, you have given training examples to the model and you have got some hypothesis. Again you have, what you did, again you have changed the training examples, again this has given to the model, again you have got one more hypothesis. So likewise you will be getting different hypotheses, H1, H2, H3. So different hypotheses you are getting. So you don't know which is the best among all these hypotheses. Okay, so for calculating the likelihood or calculating their probability, so which has highest probability, so for that we will be using MAP, maximum posterior probability. Okay, so okay, so calculate all the posterior probability by using this formula. What is this formula? This formula is Bayes theorem formula. ఓకే, సో మనం Bayes theorem అప్లై చేసినప్పుడు మనకి ఏమవుతుంది, అన్ని హైపోథసిస్ వచ్చేసి. సో హెచ్ అంటే ఏంటిది, సింగిల్ హైపోథసిస్ ఇన్ హైపోథసిస్ స్పేస్. క్యాపిటల్ హెచ్ అంటే అన్ని హైపోథసిస్ ఉన్నాయి, దాన్ని హెచ్, ఇట్ ఈస్ రిలేటెడ్ విత్ హెచ్. అంటే ఏంటి అంటే H1, H2, H3 ఇవన్నీ డిఫరెంట్ హైపోథసిస్, దీస్ ఆర్ రిలేటెడ్ టు హైపోథసిస్ స్పేస్. సో హైపోథసిస్ స్పేస్లో ఇవన్నీ హైపోథసిస్ ఉన్నాయి. సో హెచ్ ఇన్ హెచ్, క్యాపిటల్ హెచ్. Okay, so calculate all the hypotheses by using this formula. This formula is Bayes theorem formula. Now output the hypothesis by using HMAP. HMAP ఎందుకు యూజ్ చేస్తే మనకు అన్ని హైపోథసిస్ వచ్చినాయి, మనం ఏం చేయాలి, ఇప్పుడు దాంట్లో ఏది బెస్ట్ హైపోథసిస్ అది మనం కనుక్కోవాలి. సో విత్ ద హైయెస్ట్ posterior probability we will be using this particular formula to get the best hypothesis. Okay, now let us suppose P of H and P of D by H to be consistent with the following assumptions. And now you observe some new examples. Okay. What is the probability of that particular examples are true with the statement you have made? మనకి అవుట్పుట్ వచ్చింది. అవుట్పుట్ కొత్త ఎగ్జాంపుల్ కి ఎంత కరెక్ట్ we want to prove. Okay, whether new means example ఏంటి అని అంటే కస్టమర్స్ ఉన్నారు. ఓకే, బ్యాంక్ లోన్ ఎగ్జాంపుల్ ఏంటి అని అంటే if you take this probability of hypothesis becoming true that we have to find here. So example ఏంటి అంటే బ్యాంక్ లోన్ ఉంది. బ్యాంక్ లోన్ లో 95% customer who take loan have cleared the loans. ఇది నా స్టేట్మెంట్. సో దిస్ ఇస్ మై ఫైనల్ హైపోథసిస్, ఫైనల్ అవుట్పుట్ నాకు వచ్చింది. ఓకే, సో దిస్ ఇస్ కాల్డ్ as prior probability of the hypothesis. Now what is happening if I am giving new data, whether the new customers are clearing the loan or not, that I have to check, that I have to see. పాతదానికి అన్నిటికీ అవుట్పుట్ వచ్చింది. ఓకే, ఇప్పుడు కొత్తది ఇచ్చాను అనుకోండి, కొత్త దానికి కూడా ఐ హ్యావ్ టు గెట్ ద కరెక్ట్ అవుట్పుట్. కొత్త డేటా ఇస్తే దానికి కూడా మోడల్ అనేది అక్యురేట్గా ప్రాసెస్ అవ్వాలి. మీన్స్ ఇట్ హ్యాస్ టు గివ్ ద రిజల్ట్. ఓకే, నౌ pH and probability of H and probability of D by H to be consistent with the following assumptions. So what we are doing, we are assuming something. So what are those? That is nothing but the training data D is noisy free. అంటే ఏంటి, మనం ఏదైతే డేటా తీసుకున్నామో దాంట్లో నాయిసీ డేటా లేదు, డిస్టర్బెన్స్ లేదు, ద డేటా ఈస్ క్లియర్. అది మనం అజంప్షన్ చేసుకున్నాం. నెక్స్ట్ we are assuming that the training data is noisy free. It does not have outliers, it does not have missing values, it does not have duplicate values. So all these things. Okay, so that is nothing but D is DI is the data, that is equal to C of Xi is nothing but the concept. అంటే starting table లో మనం చూసాం ఏంటి అని. So this is the table which we are having. Okay, so hall ticket number, name, okay, marks, result, mark 1, mark 2 and result. So hall ticket number 1 ki name A, marks 20, marks 20. So result ఏమని వచ్చింది, fail అని వచ్చింది. 2 B, next 50, 70. Result ఏమని వచ్చింది, pass. So this is the data which we are having. This is the training data. So this is noisy free. Okay, so what is DI? DI is this particular data, single instance data, that is equal to CX of I. CX of I అంటే ఏంటిది, రిజల్ట్ ని మనం కాన్సెప్ట్ అనుకుంటున్నాము. X of I అంటే దాని అవుట్పుట్ ఏంటిది, ఫెయిల్ అని. సో దట్ ఈస్ DI is equal to C of XI. ఓకే, సో అంటే ఏంటి అని అంటే either it is yes or no, whether the customer is defaulter or not, whether the customer is loyal customer or not, whether the customer is genuine or not. So all these things, whether the student is pass or fail. So likewise we are seeing. So this is nothing but concept. Okay, so whatever the concept which is there in the training data, that is noisy free. So that we are assuming here. Next, the target concept C is contained in the hypothesis space H. మనం ఏమనుకుంటున్నాము, టార్గెట్ కాన్సెప్ట్ అనేది హైపోథసిస్ స్పేస్ H లో ఉంది అని అజ్యూమ్ చేస్తున్నాము, ఉంది అని అనుకుంటున్నాము. We have no prior reason to believe that any hypothesis is more probable than any other. Say in hypothesis space. Okay, so that is H1, H2, H3. So ఇట్లా మీకు డిఫరెంట్ హైపోథసిస్ వచ్చినాయి, అవుట్పుట్ వచ్చింది. సో ఇవన్నీ హైపోథసిస్ స్పేస్ లో ఉన్నాయి. Now you don't have any knowledge about which hypothesis is more likelihood or which hypothesis is having higher probability. Okay, so you are having different hypotheses, you don't have any knowledge about this. ఓకే, ఏ హైపోథసిస్ కరెక్ట్గా అక్యురేట్గా రిజల్ట్ ఇస్తుంది మన డేటాకి, మన డేటా సెట్కి. ఓకే, సో that you don't have, that prior knowledge you are not having. Okay, so what you have to do, we have to train the model, we have to make the machine learn from the training examples which are given, and calculate the probability for all the hypotheses and find out the hypotheses which have maximum probability of being consistent with that particular training example. So that is called as map. So that is one done by using map. Map is nothing but maximum posterior hypothesis. Okay, so here given there are assumptions, what value should be specified for probability H. So what we are doing here, given no prior knowledge that one hypothesis is more likely than another, it is reasonable to assign the same prior probability to every hypothesis H in H. అంటే ఏంటి అని అంటే we don't know. Hello. అవునండి, ఎవరండి? హలో, ఒక నిమిషం, నాకు మళ్ళీ కాల్ చేస్తాను, నా క్లాస్ ఉందమ్మా ఇప్పుడు. Sorry guys. Okay, so we don't have any prior knowledge which particular hypothesis is the best one. Okay, one hypothesis is more likely than another. Okay, so we don't have any prior knowledge that one hypothesis is more likelihood than other. So it is reasonable to assign, it is reasonable to assign the same prior probability to every hypothesis H in H. What we are doing, it is reasonable to assign same prior probability. When there is no prior knowledge about that particular hypothesis, what we have to do, we have to give same probability to all the hypotheses. And H1 ki, H2 ki, H3 ki. So what we have to do, we have to give 0.3 and 30%, 0.3, 30%, 0.3, 30%. And then probability of having H1 is 30%, probability of H2 is having 30%, probability of H3 is having 30%. Okay, so when there is no prior probability, you have to assign same prior probability to every hypothesis H in H. Okay, so now furthermore, once we assume that is contained in H, we should require that these prior probabilities sum to 1. So furthermore, what we have to do, ఇప్పుడు నేను ఇంతకుముందు ఏమని చెప్పాను, H1 కి 0.3 అసైన్ చేశాను, H2 కి 0.3 అసైన్ చేశాను, H3 కి 0.3 అసైన్ చేశాను. సో నేను మీకు ఇంతకుముందు ప్రీవియస్ క్లాస్లో ఏమని చెప్పాను, వాట్ ఎవర్ ద అవుట్పుట్ విచ్ యూ విల్ గెట్, that should be in between 0 to 1. Okay, so if you add all these things, what will happen, it is somewhat nearer to 1. So the same thing I am saying, prior probability sum to 1. Whatever the hypothesis which you will get, that should be summed and it should be in between 1 or it should be 1. Okay, so together these constraints imply that we should choose probability of H that is equal to 1 by modulo of H. And ఏంటి అని అంటే number of hypothesis in hypothesis space for all H in H. ఒకవేళ మనకి ఏ ఒక్కటి కూడా బెస్ట్ హైపోథసిస్ అని రాకపోతే అన్ని హైపోథసిస్ మనము ఈక్వల్ ప్రాబిలిటీగా తీసుకుంటాం మనం. ఓకే, సో దాట్ విల్ నాట్ బి దేర్ if any case, in any case if it is there, that I will tell you how to get the best one. Okay, that we will see next. So the probability of data D Given hypothesis H is 1 if D is consistent with H and 0 otherwise. Probability of data D for given hypothesis H is 1 if they are consistent. అంటే ఏంటి అంటే H అనేది కన్సిస్టెంట్ అయితే మనకు అవుట్పుట్ అనేది 1 వస్తుంది. H అనేది కన్సిస్టెంట్ అంటే 0 వస్తుంది. ఇది మనం అన్ని అల్గోరిథమ్స్ లో we have seen from all the from candidate elimination algorithm, from neural networks, for decision tree, all we have seen in the same way. Okay, so probability of data per hypothesis if is equal to 1, that is nothing but each and that particular hypothesis is consistent with the data training examples. If it is not, if we are getting 0, that is nothing but it is not consistent with the data here. Okay, now let us consider the first step of this algorithm, which uses Bayes' theorem to compute the posterior probability of each hypothesis given the observed training data D. So now consider this again. So sorry guys, I have missed one slide in between. Okay, no problem. So now what we are doing, we are recalling the formula here, that is P of H by D. So here if you say H is not accordance with D and H is not consistent with D, that means posterior probability of D given H will be 0. ఓకేనా, ఇంతే, ఇదే కదా మనం అనుకుంది. ఇక్కడ 0 వచ్చిందంటే హైపోథసిస్ అనేది కన్సిస్టెంట్ కాదు డేటా తోటి. సో దట్ వీఆర్ థింకింగ్ హియర్. ఓకే, నౌ కన్సిడర్ H. The hypothesis made is consistent with D. The training examples observed, whatever the training exams which I have observed, D is consistent with H. Okay, so here okay, so what we are doing here, H is not consistent with D. Okay, that means posterior probability of D given will be 0. అది మనం ఇంతకుముందు అనుకున్నాం. Okay, now consider H hypothesis made it is consistent with D, H consistent, and the training exams observed D is consistent with H. Okay, H consistent కాకపోతే 0, H consistent అయితే 1. Okay, so ఇక్కడ మనం ఏం అనుకుంటున్నాం, H consistent with the training examples D. So here the formula is P of H by D is equal to 1 into 1 by modulo of H by P of D. 1 ఎందుకు, when D is consistent with H is 1. సో అది మనం అస్యూమ్ చేస్తున్నాం. ఇంకోటి ఏంటి, probability of H do not have prior probability knowledge, we assign equal probability. Hypothesis different hypothesis ఉన్నాయి. ఓకే, సో H1, H2, H3 ఉన్నాయి. సో దీంట్లో ఏదో ఒకటి కన్సిస్టెంట్ అని వచ్చింది. సో దాన్ని మనం ఏం అసైన్ చేస్తున్నాం, 1 అని అసైన్ చేస్తున్నాం. సో దట్ ఈస్ 1. ఇప్పుడు H1, H2, H3 ఇవన్నీ హైపోథసిస్ ఉన్నాయి. ఓకే, ఇవన్నీ కన్సిస్టెంట్ కాదు, మనకి తెలియదు ఏది కన్సిస్టెంట్ అని. సో మనం ఏం చేసినాము, ఇవన్నిటికి ఈక్వల్గా అసైన్ చేసినాం. ఎట్లా, దట్ ఈస్ 1 by modulo of H. That is assigned with 1 by modulo of H by P of D, probability of D. So that is, we will be getting P of D. P of D etla vastundi ante, that is equal to Vs H comma D by modulo of H So this is the formula which we will be substituting here. Okay, so P of D and enti number of hypotheses in version space. Sorry, probability of observing training examples irrespective of any hypothesis. So మనము అన్ని training examples ని observe చేసినాం irrespective of all the hypotheses. D is nothing but data set. Probability of data set ఏది hypothesis consistent అనేది మనం చెక్ చేస్తున్నాం ఇక్కడ. ఓకే, సో దాన్ని కనుక్కోవడానికి we will be using that is equal to VS అంటే in the previous class we have seen VS అంటే version space. So number of hypotheses in version space consistent with D by we are giving equal importance to the all the hypotheses. All the hypothesis is represented with modulo H. Any hypothesis unte anni hypothesis ni మనం ఎట్లా రిప్రజెంట్ చేస్తాం మాడ్యూల్ H తోటి రిప్రజెంట్ చేస్తాం. ఓకే, నౌ okay, so here what has happened, P of D should be represented with this formula. Okay, so then what we will get, show you. So guys, don't confuse, these are all statistical formulas. You have to by heart it again and again. Okay, so P of H y D equals to 1 into 1 by modulo H by P of D. Okay, so P of D is equal to version space of H comma D by modulo H. Now we are substituting P of D formula here. 1 into 1 by modulo H by VS version space H comma D by modulo H. Okay, now if you see in this formula, removing the denominator and numerator, so modulo H you can cancel it. So what will happen, you will get the formula as D by version space of H comma D. So this is the formula you will be getting here if H is consistent with D. H consistent అప్పుడు 1, ఒకవేళ H consistent కాదు అప్పుడు మనం ఏం చేస్తాం, ఈ ఫార్ములా యూజ్ చేస్తాం. ఈ ఫార్ములా యూజ్ చేసి H is consistent with D అని ప్రూవ్ చేస్తున్నాం. Okay, from the version space we are proving all the hypotheses, whatever the hypotheses which are there, from that we have to prove one hypothesis is consistent with the training data. So we want all the probability where H is accordance with training examples D, but we want maximum out of it. మనకు అన్ని హైపోథసిస్ వచ్చినాయి, అన్ని హైపోథసిస్లలో ఏదో ఒక్కటి మాత్రమే తీసుకోవాలి, మనం అన్నిటిని తీసుకుంటేదా మనం. ఓకే, సో that is done by using this particular formula. So that is called as MAP. MAP అంటే maximum posterior hypothesis. But we want to consider only posterior problem. How many are existing? So that is done by using this particular form. So what are the number of hypotheses in version space that are consistent with the training examples? అన్ని hypotheses వస్తాయి, అన్ని hypotheses version space లో ఉంటాయి. ఆ version space లో ఎన్ని hypotheses మనకి ట్రైనింగ్ ఎగ్జాంపుల్స్ తోటి accurate గా consistent, accurate గా likelihood అది ఫైండ్ అవుట్ చేయాలి. అది ఫైండ్ అవుట్ చేశాక దాంట్లోకి వెళ్ళి మనము we have to find which one is the best hypothesis, which one is the accurate result, which one is the correct result. that we have to find. Okay. So to summarize, Bayes' theorem implies that posterior probability P of H by D under our assumed PH and PD by H is this particular formula. So next is evaluation of probabilities which are associated with hypothesis. H2, H3, H4 ఇట్లా అన్ని హైపోథసిస్ ఉన్నాయి. మనం ఏమనుకుంటున్నాము, ఇనిషియల్లీ ఆల్ ద హైపోథసిస్ ఆర్ having same probability, అన్నిటికీ ఈక్వల్ probability ఉంది. Okay, so that is the in figure A. Okay, in figure A, initially the probability of the hypothesis, it is linear. All are sharing equal hypothesis. Okay, as training data accumulates, the posterior probability for inconsistent hypothesis become 0. Example enti anante, initially you say 50% of Indian population are recovering from COVID. Idi mana statement, idi na hypothesis. Okay, ee statement istunane. Now we have started gathering more and more data about the patients who are recovering. New data and gather చేస్తున్నాను. Okay, so likelihood of hypothesis is increasing. ఇంతకుముందు ఎంత ఉండే, 50% ఉండే, ఇప్పుడు ఏమవుతుంది, 60% అయింది, తర్వాత 70% అయింది. రిజల్ట్ అనేది ఇంక్రీజ్ అవుతుంది. సో నౌ అబ్జర్వ్ 10 million Indian population. From that 90% recovered. What will happen? Then hypothesis will become narrow and grow. Okay, so that is in C. ఇదేమో కాన్స్టెంట్ గా ఉన్నది, అది 60% ఇంక్రీజ్ అవుతున్నది అది 50% స్టార్టింగ్, అది లీనియర్ గా ఉంది. తర్వాత కొత్త డేటాను తీసుకొని నేను ఇంక్రీజ్ చేశాను, దట్ ఈస్ 60% to 70% అయింది. తర్వాత ఏమైంది, ఇది గ్రాడ్యువల్ గా ఇంక్రీజ్ అయింది, 90% అయింది, నారోగా గ్రో అవుతుంది అవుట్పుట్ అనేది. Okay, so here what is happening in figure A, sharing same probability, అన్నిటికీ ఈక్వల్ గా షేరింగ్ ఉంది, అన్ని హైపోథసిస్ అన్ని అవుట్పుట్ కి సేమ్ ఉంది. ఓకే, సో ఇప్పుడు
మ్యామ్ we can't see the screen.
Can't see the screen. Now?
Yes ma'am, now we can.
Okay, so in case of figure A, what is happening, you are having equal share, equal probability, అన్ని అవుట్పుట్స్ కి ఈక్వల్ గా ఉంది. Okay, it is having linear growth. But in case of probability B, hypothesis B, in figure B, what is happening? When training example 1 is observed, అంటే data 1 అంటే first ఒక training example తీసుకున్నాను. Okay, there is more knowledge about that particular property of hypothesis. Say ఇవన్నీ హైపోథసిస్ ఉన్నాయి, H1, H2, H3, H4 ఉన్నాయి. దాంట్లో ఏమవుతుంది, H1, H2 ప్రాబిలిటీ ఏమవుతుంది, రెడ్యూస్ అవుతుంది విత్ సపోర్ట్ టు D1, బట్ H3, H4 ఇస్ గివింగ్ గుడ్ రిజల్ట్ టు D1. ఒక డేటాకి H3, H4 మంచిగా ఇస్తుంది, సో ఇది గ్రాడ్యువల్గా ఇంక్రీజ్ అయింది. సో ఇఫ్ యూ టేక్ మోర్ డేటా, ఓకే, సో వాట్ ఈస్ హ్యాపెనింగ్ హియర్, H1, H2, H4 is not supporting to D1 తీసుకున్నారు, దాంతోపాటు D2 కూడా తీసుకున్నారు. ఓకే, డేటా 1 తీసుకున్నారు, దాంతోపాటు డేటా 2 సెకండ్ డేటా కూడా తీసుకున్నారు. ఓకే, అప్పుడు ఏమైంది, ఆ రెండింటిని మీరు ఉన్న హైపోథసిస్ తోటి కంపేర్ చేస్తున్నారు. కంపేర్ చేసేటప్పుడు ఏమైంది, H1 H2 H4 అవిటికి సపోర్ట్ చేయట్లేదు, H3 మాత్రం సపోర్ట్ చేసింది, ఒకటి మాత్రం సపోర్ట్ చేసింది. సో H3 is consistent with the training example D1 and D2. What is happening? Its probability is increasing. So this is evolution of probability which is associated with hypothesis. So now we keep observing the training examples with much data. Okay, data ఇచ్చిన కొద్దీ మనకి ఏమవుతుంది, ప్యూరిటీ అనేది పెరుగుతూనే ఉంటుంది మోడల్ జనరేట్ అయ్యాక. ఓకే, now observing all which hypothesis will hold the good for all the data. So that is called as most probable hypothesis. Okay, every consistent hypothesis is therefore a map, maximum posterior hypothesis. So the last topic, map hypothesis and consistent learners. So every hypothesis consistent with the D is a map. Okay, we will say that a learning algorithm is a consistent learned provided it outputs a hypothesis that commits zero errors over the training examples. So now any learning algorithm which is as a consistent learner, any learning algorithm is a consistent learner when it makes zero errors, when it makes zero errors in prediction, then we say that each and every learning algorithm is a consistent learner. So in this case we say learning algorithm is a consistent learner. So if we take given the above analysis, we can conclude that every consistent learner outputs a map hypothesis. And when we take neural network learner, neural network algorithm తీసుకున్నారు, decision tree algorithm తీసుకున్నారు, candidate learner algorithm తీసుకున్నారు. So if identifies the map hypothesis and a best hypothesis, then we say that the learner is consistent learner. You can take any particular learner, ఏదైనా లెర్నర్ కావచ్చు, న్యూరల్ నెట్వర్క్ లెర్నర్ కావచ్చు, బ్యాక్ ప్రొపగేషన్ కావచ్చు, క్యాండిడేట్ ఎలిమినేషన్ కావచ్చు, ఫైండర్స్ కావచ్చు, డెసిషన్ ట్రీ కావచ్చు, ఎనీ లెర్నర్. ఇఫ్ యూ టేక్ ఎనీ లెర్నర్, ఓకే, if it is consistent, if it identifies the consistent, or if it identifies the map, that is maximum posterior hypothesis, then we say that then we say that the particular learner is consistent learner. Okay, so here every hypothesis will have prior probability. That is P of Hi is equal to P of Hj for all I comma j in H. And here if we assume deterministic noisy free training data, ante enti ante deterministic ante enti ante data is not random, it is static. That is called as deterministic. ఏదైనా డేటాలో which the particular data is static, okay, and we don't have any noise in that particular data. Okay, if we take that particular data, then to that particular data it gives us the consistent hypothesis to the learner. Consistent learner అంటే ఏదైనా అల్గోరిథం కావచ్చు, ఆ పర్టికులర్ లెర్నర్ కి ఆ పర్టికులర్ హైపోథసిస్ కన్సిస్టెంట్ అని వస్తుంది. సో దట్ ఈస్ P of Hi is equal to P of Hj. So what we are doing here, assuming data is deterministic, assuming data is noisy free, assuming all hypotheses in the hypothesis space share equal probability. So then if hypothesis is consistent with training examples, then whatever the probability which is there, that is given as 1, otherwise it is given as 0. Okay, so this is about brute force base concept learning. Guys, till now, any doubts? Guys, I am saying to you again and again, just by heart the formulas. Okay. So, any doubts regarding anything? We will be having much formulas in machine learning. Guys, any doubts regarding anything? Okay then. Paridhi or Saikat or Sandeep or anyone, just send me the attendance, today's attendance. Okay? Shall I tell them to leave or stay? Guys, can you hear me?
Yes, ma'am.
Will you take the screenshot?
Ma'am, I think Shaikat has taken here and done, ma'am.
Okay, right. Thank you. Right, guys, you can leave.